Welcome to Applied Animal Feeding Concepts videos, and today we're going to visit a little bit about the concept of dry matter. And so the concept of dry matter is referring to the weight of a feed after when the water's been removed. And so literally the dry weight. And so in nutrition labs and those types of places, we would actually put a feed sample in an oven for about approximately 48 hours until it was completely dried, and collect the beginning weight, the ending weight, and figure out what percent dry matter was remaining after we removed the moisture. And this will come into importance when we think about, in particular, our herbivores that are on forage diets. This applies to all animals, but when we think of those that really forage diets, the amount of water in that diet is so variable. It can range from hay, which is about 10% water or 90% dry matter, to silages that are about 30, that are about 65 to 70% water, leaving only about 35% dry matter. And so feeds can vary from one extreme to another. Fresh pasture, really green, lush pasture, is actually about 20% water, 80% water, I think, in dry matter, can you tell? Which is about 20% dry matter. And so our animals' feeds vary quite a bit, and as a result, we need to be able to know how that water weight can impact the nutrients being delivered to our animals. And that's where the concept of dry matter is going to be extremely important. In contrast to dry matter, we have the term as fed, or the as fed basis. Okay, and as fed is referring to how that feed is presented to the animal. Okay, so when we offer our sheep a diet they're grazing fresh pasture, and that pasture is high in moisture, that's the as-fed. Generally, when animals are fed pounds of feed on an as-fed basis, it's going to be diluted. The nutrients will be diluted because of that water in the feed. And we'll talk about, we'll create a visual here in just a second explaining the relationships between dry matter and as-fed. There is a third term that you'll sometimes hear in reference to nutrients of feeds, and that's air dry. And that is assuming approximately 90% dry matter. So that's assuming that the feed is mostly dry, but not quite 100%. And this is actually what most feed tags have reported, unless specified differently. So if you look at a feed label, that's generally what you're going to see. And so let's break down this concept of dry matter a little bit more. So, for example, let's pretend that I have a bale of hay. Again, we have to pretend Selena's artwork is to scale and all of that. We know that in our animal's feed, we're feeding it to provide the 6 nutrient classes. This is why we feed and take care of our animals, to supply optimal nutrients for their growth and development. So these are going to be things like water is part of it, carbohydrates, fats, proteins, minerals, vitamins. Okay? We need to remember that carbs, fats, and proteins supply energy, calories, to our animals. Okay? And so as a nutritionist, water is probably the easiest nutrient for us to supply. And so we need to account for water in our feeds, but we don't necessarily want to be feeding water. And we want to have the most value for our dollar. And so when we're feeding nutrients, we want to get them into the animal at the appropriate levels. So we need to understand how the 5 other nutrient classes relate to water in the feed. So if we take our feed that I drew, and we're expressing this on an as-fed basis. So this is how it's presented to the animal. And I mentioned this was a bale of hay. So we know that about 10% of this is going to be water. So we're going to just estimate about 10% water. That is going to leave the remaining 90% of what we call the dry matter, or DM. All right, so in this dry matter, this is where we are going to find all the other nutrients that we're wanting to feed our animals. Protein, carbs, and that's including fibers and sugars and starches and everything. The fats, vitamins, and minerals are all going to be packaged into that dry matter. And that's what we're really interested in supplying nutrients for our livestock. And so if we were to take and literally pull out the water here and go with the remaining amount of feed, again, pretend this is to scale. So if we just draw a dashed line and we've removed the water, now what we have is the true dry matter basis for this feed. So now what we're going to see is if we took that bale of hay and dried it, we're going to realize that, okay, on a dry basis, that bale of hay should be lighter weight, correct? Because we've removed the water, we have removed the water, so we have removed some of the mass of that hay as well. So it's lighter weight. In contrast, an animal, when we present it as fed feed, that is going to be heavier weight. So just to make sure we understand that a feed with the water in it is going to be heavier than a feed without the water, which makes sense when you think about it. The second aspect is on this as-fed basis, when we take a look at it, we need to realize that water acts as a diluent. So if we were looking at concentrations of nutrients, things like percentages, parts per million, we are going to actually have lower concentrations when nutrients are expressed on an as-fed basis as compared to the dry matter basis because of that dilution effect of water. So, for example, if the hay was 15% protein and on an as-fed basis, we would expect that protein value to actually be more so when we remove the water and affect the concentration of those nutrients because of that dilution factor. So what this does as a nutritionist is we're now able to account for a little bit more accurate reflection and a little bit more precision in being able to get the protein, carbs, fats, vitamins, and minerals into our animal by balancing on a dry matter basis and then going back to as fed. It allows us for a little bit more precision to consider the actual amounts of nutrients going in, not a diluted amount or a lighter weight amount. And so because of the variability in the feeds that we have on moisture content, we're just going to essentially mathematically remove moisture from the consideration and focus on the other 5 nutrient classes when we're balancing rations on a dry matter basis. The next major concept that we need to understand to get us set up for success in applied animal feeding is the concept of percentages. And this is, everybody groans, but we need to understand truly what a percentage does and how to work with percentages to be successful in some of the basic concepts of applied animal feeding. And so when we think about a percentage, I define the percentage as a part of something over the entirety or the whole of something times 100. And so, for example, if we were to say that, we'll stick with the bale of hay example. If we knew that the hay was 90%, had 90 pounds of dry matter out of 100 pounds as fed, and just in my world, hashtag means pounds, then we would be able to simply convert that and set it up as an equation and get to our 90% dry matter. And so what we're saying is that 90% of a bale of hay could be dry material. So as another example, what if our alfalfa bale of hay weighed 125 pounds? And we wanted to know how many, the question is, how many pounds of dry matter? Okay, that's our question in 125 pounds. And I'll make sure to make a note of this as fed. Okay, so to do that, we would simply take the weight times the percent dry matter on a decimal basis. So for this case, it'd be 125 pounds as fed times 0.90. And that's going to equal, verifying since I'm making a video, that would be 112.5 pounds of dry matter. If we go back to our previous example where we talked about how water makes feeds heavier, then if we are going from as fed to dry matter for a weight, we should be getting a smaller number. We're removing the water, so we should have less pounds. And you know what? That's what we did. And so that's an example of how that percentage works. Now, if we were to go this other direction, and perhaps we had, let me do this in a different color here, 100 pounds of dry matter of this same hay. So now we wanted to know, in this case, our question is, how many pounds as fed? So we're going to do the opposite. We're going to take this, the weight, 100 pounds of dry matter, and divide, in this case, by the percent dry matter on an as-fed basis. Okay? And so we're always, when we're converting between pounds of as-fed and pounds of dry matter, we always use the decimal form of the dry matter. We don't use the moisture percentage or anything like that. We use the dry matter percentage. Let's get this up just a little bit. And so if we do this, we find out that if we had 100 pounds of dry matter and we have to add water back into it, we should be getting a heavier number. So 100 divided by 0.9 is going to give us 111.1 pounds as fed. So we went back to a heavier number. So we've talked about what the concept of dry matter and as-fed basis represents. We've talked about using percentages and how they work in converting from dry matter to as-fed and weights. We also need to understand how these percentages, particularly of dry matter, work on nutrient concentrations. It's hard to write on a white pad neatly. Actually, for me, it's hard to write neatly in any form. And so this is where, for example, say you send a feed off for analysis and it comes back that it's 80% dry matter. We'll say feed A. Comes back and it's 80% dry matter. And it mentions that there's 15% crude protein on a dry matter basis. And so you're wondering, okay, but that's on a dry basis. What about as fed? What would that percentage of protein be as I presented it to my animal? And so this is where we could set up a simple little formula that would allow us to be able to convert between the two. And so what I do is generally set it up with as fed on one side, and we're going to be setting up a cross multiplication, dry matter on the other side. And we're just going to set up and figure out the amount of the nutrient out of the percent dry matter on this side, and the amount of nutrient on a dry basis out of, in this case, it'll always be 100% dry matter because we're on a dry basis, so it's going to be perfectly dry. So for the example I've given, we would know what we're wanting to solve for is the amount of nutrient on the as-fed basis. But we know that in 100% of that as-fed feed, 80% of it is going to be dry matter. And we're going to compare that relationship to 15% protein on a dry matter basis out of 100% dry matter. So we're comparing the two relationships. And so the relationship of nutrient to the feed as fed, and that relationship of nutrient to the feed on a dry basis. So now the next question is to simply cross multiply. So we'll wind up with 100x is equal to 1200. If we divide both sides by 100 and isolate x, we're left with 12% crude protein on an as-fed basis. So now going back to our question of does this make sense or not, we know that we're going from a dry concentration, which is highly concentrated, to a somewhat diluted concentration. So we should be getting a smaller number. Now, we could flip this scenario around where, say, if we have our second feed B, and we know that that feed is 70% dry matter. And however, on this feed, we know that it's 10% crude protein as fed. So as it goes to the animal, that's how much protein is in it. But we really want to know how much actual protein is in this feed if it wasn't diluted. So we're going to use the same formula, and in this case, we know how much protein on an as-fed basis, so we can set that up. That at 100% as-fed, we have 70% of its dry matter and 10% is protein. And we're going to look at, that's a multiply sign, that relationship. What we don't know is the amount of nutrient on a dry matter basis, that percent protein on a dry basis. But we do know that it's 100% dry matter. So for this problem, we wind up with 70x is going to equal 1,000. If we divide both sides by 70, x is going to be 14.3% crude protein on a dry matter basis. And when I'm beginning and teaching students to first start with dry matter and as-fed, I'm really encourage people to write down the basis, dry matter or as-fed. Frankly, to this day, I still write it down just to make sure I don't get things mixed up. And on this direction, what we learned is that we're going from an as-fed basis. We know that it's going to be the diluted value of 10%. So we know that we probably need to get a larger number. And in this case, we did get a larger number because we removed the water and increased the concentration of protein just by removing that water and the dilution effect that it can have. And so that kind of wraps up just kind of the concepts of how to convert between the two. If you're in my Animal Science 230 class, you will be doing some problem sets that are going to help you practice this concept so that you can really understand how these percentages interact with each other.